Good morning to all from the editorial board of Build Up Portal. For the ones who are attending a Build Up webinar for the first time, welcome. For our returning audience, thank you for renovating your interest. It is a pleasure to host today's webinar entitled Holistic and Reliable European Voluntary Certification Scheme to Trigger Deep Renovation of Non-Residential Buildings, which is organized in collaboration with Aldren project. I would like to invite you all to contribute and participate in this webinar. You can ask questions by typing in the box on the right side of the screen. They will be answered at the end, after the presentations. You can also contribute to Build Up Portal. Build Up is a collaborative platform in the field of energy efficiency in buildings. It is continuously updated and it represents one of the key sources of information on the topic of energy efficiency. You can register and become a member of the community, and you can also upload news, events, present case studies, results from my projects, and so on. I invite you all to navigate the portal. In the Learn section, you will find all the podcasts of the past webinars, so it is possible to listen to all the previous presentations. Each month, the editorial team selects a topic of the month to encourage the community to focus on one specific topic. For example, the topic of March is certification and energy labeling, where we are hosting today's webinar. Now, I would like to present the agenda and introduce the speakers. First, Mathieu Rivaillant, Head of Division Energy and Environment Department at CSTB, French Scientific and Technical Center for Buildings, will introduce the Aldren project. Then, Jana Benzalova, Executive Manager and Researcher at ENBEE, Environment and Building Energy Efficiency, will discuss the European Voluntary Certification Scheme, Energy Ratings. Then Robert Cohen, Technical Director at Verco, will address the gap between calculated and actual energy performance. The next speaker will be Pavel Barkotsky, Associate Professor at Technical University of Denmark, who will address health and well-being and tile indicator. Then Olivier Greslu, Research and Expertise Project Manager at CSTB, will explain the link between energy performance, health and well-being to financial valuation of buildings. Finally, Marta Maria Cesana, Research and Expertise Project Manager for Politecnico di Milano at Lecco Campus, will present the Aldren Building Renovation Passport and renovation strategies. Now, I would like to leave the floor to Mathieu. Please, we can start the session.
Thank you very much, Julia. Ladies and gentlemen, good morning. We are very pleased to get the opportunity today to introduce you to the Aldren project, and we would like to sincerely thank Build Up for making it possible. I am Mathieu Rivaillant from CSTB, France, and with Johan Zengibel and Olivier Greslu, I am leading the Aldren project. Aldren actually means Alliance for Deep Renovation. The Aldren project is a European Horizon 2020 project focused on the development, implementation, and market uptake of a performance assessment and certification scheme for deep renovation projects, especially for office buildings and hotels. Within Aldren, 8 partners are joining efforts to contribute to an increase in the non-residential buildings energy retrofit rate and quality. Aldren partners represent complementary expertise and positioning. CSTB, DTU, and Polemy are technical and research institutes. Certivea and IVE are 2 French and Spanish building certifiers. NB and Verco are consulting companies. And as you know, RIVA is a professional association gathering more than 120,000 HVAC designers, engineers, technicians, experts across the EU. We are deeply convinced that this is the right time and scale, European scale, to promote and develop projects and schemes as Aldren. No need to recall with you both the ambitious targets that have been set at European scales in terms of energy consumption and climate mitigation, and still the very low renovation rate in terms of both volumes and energy performance. We have to draw lessons from our past experiences and admit that decision makers, property owners, building stock managers, investors will not renovate buildings for predicted energy savings. To engage the building sector towards deep renovation and net zero energy buildings and renovation, we have to enlarge the vision of deep renovation value to assess and certify these additional values and to develop a common language within the deep renovation stakeholders. These are our objectives for Aldren. Today, more than 34 EPC schemes coexist at EU scale as national and regional transposition of the EPBD. To engage the building sector in deep renovation, NZEB, to our eyes, it remains fundamental to raise confidence among property owners and investors, to respond professional expectations in terms of reliability, comparability, transparency, quality. From the very beginning, and extending the European Voluntary Certification Scheme, EVCS, Aldren contributes to set and promote quality European benchmarking tools regarding non-residential buildings energy performance based on international ISO standards. Aldren contributes to set methods and tools to design for performance and then verify energy performances. Jana and Robert from NB Inverco will further present the Aldren outcomes in terms of reliable, transparent, comparable quality benchmarking tools and energy performance verification. To engage the building sector in deep renovation, and that again, it is also crucial to assess the benefits beyond energy performance and include comfort, health and well-being, building value according to an holistic approach. The Aldren project has set an assessment approach called TEL, encompassing thermal, acoustic, indoor air and lighting performances for deep renovation. Pavel from DTU is going to elaborate further on the topic. Beyond energy and holistic performances, we definitely believe that tangible roadmaps for deep renovation and NZEB are essential to engage the building stakeholders. These roadmaps are to take into account the owner's expectations, needs for maintenance, ROA, immediate candidates, etc. Deep renovation actions may be articulated according to a step-by-step approach, ensuring consistent integration over time within and collected within a building passport. Marta from Polymy is also going to drive us through that topic. Last, the holistic assessment of deep renovation performances has to be understood and shared among the building stakeholders, from the boiler room, let's say, to the boardroom. This is the reason for the Aldren Alliance. Nobody can trigger the building energy renovation alone. The building owners need support from the financial sector, professionals, etc. The successful implementation of the ambitious EU targets on energy mitigation and climate change requires the involvement of the whole implementation chain, from the legislative level, where objectives are defined, to the implementation on field by qualified professionals, and all of this should be coherent, consistent, and ambiguous. To respond to the previous objectives and challenges, Aldren outcomes have been designed as 6 complementary modules Oh, sorry, I'm not sure. Yeah, we can move the slides. Okay, fine, thank you. The Aldren protocols are applied, tested, and consolidated on 20 pilot buildings over the EU, in hotels and office buildings in Spain, France, Italy, Slovakia, UK, and Belgium. The pilot studies are actually ongoing. Aldren is to offer opportunities to a wide range of stakeholders, to property owners through increased reliability, comparability, quality mark, risk, and cost reduction, to the financial sector through improved predictability of investment and harmonized procedures, to industrials setting a level playing field based on fair competition and technical neutrality, to building professionals increasing professional skills based on best practice and to be used EU-wide. The Aldren market uptake is offered through different forms. The Aldren architecture being modular, it allows to integrate one or more Aldren protocols in existing voluntary certification scheme, such as BREEAM, DGNB, BIS, or HEQE. Aldren can also be considered as a standalone assessment and certification scheme that EU member states are free to exploit to develop relevant public policies or transpose the EPBD amendments in national and regional regulations. Indeed, Aldren outcomes are related to something like 17 paragraphs of the EPBD amendments, including building stock observatory, cost optimality, building passport, evidence-based expected energy savings, etc. To conclude, we just would like to recall a few messages. First, to engage the building sector towards deep renovation and NZEB, we are deeply convinced that we have to develop and promote European building quality benchmark based on international standardized best practice. Second, and with no pleasure to recall some recent and unfortunate controversy, the building sector has to avoid a building gate. Predicted energy performances are not enough to meet our ambitions. Performances are to be verified. Third, today's building renovation have to prepare the 2050 ready buildings, thanks to consistent renovation roadmaps, building tangible pathways to the NZEB standard. Fourth, development of a common language is necessary, is essential to involve all relevant renovation stakeholders from the boiler room to the boardroom. And last, the EU Green Deal and renovation wave policies will require proper taxonomy to engage investment. European funds should be linked to EU methods and tools. The Aldren procedures offer potential solutions to the previous issues. I will now leave the floor to Jana, Robert, Pavel, Olivier, and Marta, and right after the presentations, I hope you will join Aldren. Thank you very much. Thank you.
Okay, good morning to everybody, and thank you for opportunity to present European Voluntary Certification Scheme, Energy Rating and Targets. So this is the context of my presentation, the main structure. So we will start with the main objective of Aldren Energy Performance Assessment, that is to provide a harmonized and reliable instrument and common metrics for comparability European-wide for financial measures linked to energy performance to support European climate targets, for example, in connection with green investment. Then for transparency of energy performance in property market, to give a correct information to building owner and all stakeholders involved in renovation process, with the aim to avoid a suboptimal renovation with the potential lock-in effect for decades. The aim is also to support the level playing field for products and innovative solutions and enable a common European market for software and training of experts based on European standards. The background of Aldren European Voluntary Certificate is Article 11.9 of the EPBD that says that the Commission shall, in consultation with the relevant sectors, adopt a voluntary common European Union certification scheme for the energy performance of non-residential buildings. The roles of certificates is also strengthened in the new amendment of EPBD that requires that the transparency of energy performance certificates should be improved by member states by ensuring that all necessary parameters for calculation are set out and applied consistently. The main objectives of Aldren approach are benchmark, prediction, and evidence of energy savings based on 4 technical pillars of Aldren approach that are harmonized calculation methodology, harmonized indicators, performance scale for benchmark energy performance, and common template of European voluntary certificate. The Aldren European Voluntary Certificate can stand alone or can be integrated in other existing mandatory or voluntary certification scheme. It can be complement to the national EPCs in case of more detailed analysis of energy performance is needed, for example, for big investment in renovation. The possible implementation can be similar as for voluntary smart readiness indicator. The ambition of Aldren methodology for energy rating and European voluntary certificate is to be consistent and codified with as much as possible links to European standards, directives and regulations, provide realistic results close to real energy performance. This is why the energy is estimated for local climate of building, not for standard national climate as often happens. Ambition is to be protocol simple and close to the current practice of energy experts and designers and to be performed by international experts at European level who is able to work with European standards. The aim is to provide unambiguous results based on clear inputs and choices for transparency and European comparability. The main steps in protocol, as you can see, are the data collection, calculation of indicators, estimation of rating, and energy class, and issue European voluntary certificate. Protocol takes into account also previous studies, especially for European Commission, several studies on voluntary certification scheme for non-residential buildings were performed by consortium partners. The timeline for Aldren Energy Performance Assessment is not only to issue certificate before and after renovation, but the most important is the energy assessment in the design stage to propose the best renovation solution towards nearly zero energy building without the lock-in effect. The actual result depends on quality of renovation works, and if targets are achieved or not should be confirmed by certificate issued after renovation. The calculation methodology is based on European standards developed under Mandate 480. That is the reference methodology in line with EPBD Annex 1. But any software close to the same standards based on the hourly calculation step can be used. A question for the future is the accreditation of such software and potential European calculation kernel development based on European standards. To lower the gap between calculated, predicted, and real energy consumption, a typical climate of the specific building location is used in calculation, and the typical national building use patterns are assumed. For clear definition of inputs and choices, the Aldren Annex A for overarching standard will be also developed in Aldren project. This calculation methodology based on CEN standard should support European market for products, for use of standards, for software, and also training and accreditation of experts as proposed, for example, in Horizon 2020 CENCE project. As you can see in the graph, for the same building, there are more alternatives of numeric indicator of primary energy required by EPBD. Two main indicators are used for Aldren energy class and ratings that are non-renewable primary energy balance with export of produced renewable energy counted, and non-renewable primary energy with only self-consumption of produced renewable energy. The additional indicators reported in the certificate are harmonized with EPBD and existing certification schemes to can be used by these schemes as an energy module. So, beside the energy-related indicators, also the indoor thermal comfort is evaluated beyond the energy performance of building. The common template of certificate consists of several pages. The main indicators are reported in the first page together with the thermal comfort indicator proposed by Aldren and based on European standards that is linked to reported energy. The first page of certificate is normally in blue color, but to support a green investment, the high-performing buildings are highlighted by the green certificate issued if Aldren nearly zero energy building criteria are fulfilled. These criteria are set for primary energy, energy needs, and the thermal comfort score. Next, details on energy performance are reported in next pages, but most important part is the pages with recommendations for improvement and potential savings with link to building renovation passport, which will be presented by my colleagues. The template of voluntary certificate consists also one page for reporting the results from each Aldren task. Sorry, I have to come back. Okay, thank you. Common European scale is a biggest challenge of this Aldren approach. So it is set for 3 climates and takes into account the Commission recommendation for the promotion of nearly zero energy buildings. The scale is relative based on the ratio to reference point. The reference point for different climates was set based on simulation using hourly step applied on several reference buildings of different size and different quality. And this quality was based also on review of reports from cost optimal level calculation by member states in 2013 for offices and hotels. Scale has been defined by simulation in hourly calculation step, and today it is tested on several pilot buildings. So in my last slide, you can see some examples and lessons learned from testing that are for now that the scale fits quite well to office building. On slide, you can see the results from building with full renovation where energy class A can be achieved from class F, and example of building where the full renovation was not possible. For example, in the city center was not possible to apply the outside insulation, so energy class B and C are achieved. Important finding is also that the training for use of CEN standards, especially for aggregation of the results from simulation into the final indicator, is needed and could be provided by CENSE project. So as conclusion, calculation of energy performance is not the end, it is just beginning, and it is the first step to provide inputs in other Aldren tasks, which will be presented by my colleagues. So thank you for your attention.
Good morning, everyone. I am Robert Cohen, Technical Director at Energy Consultants Verco, and I'm going to talk briefly about how to address the gap between calculated and actual energy performance in the production of building energy performance certificates. I'm going to talk about the context, the main objectives of the protocol, give you an overview of the protocol, the tools and the indicators, tell you about applying the protocol, the main steps, and tell you some key lessons that we've learnt from the pilot studies. So the context and ambition. A key attribute of Aldren's proposed harmonized energy performance rating based on the European Voluntary Certification Scheme is the verification of the rating by measurements. And this is because verified performance will increase trust in the rating. And we believe that a trusted rating should make it valued in the real estate market for offices and hotels, the two sectors that we are mainly looking at. In other words, a better energy rating will equate to a higher asset value financially. And why is this? It's because customers, whether it's the occupants of offices or the guests in a hotel, will preference buildings that have a better rating. And therefore, rents can be higher, vacancies will be lower, and that financially creates a higher yield. A higher yield necessarily creates a higher asset value. And the key consequence of this is that asset owners become justified to do deep retrofit with a better energy rating to increase trust. So the main objectives of the verification approach are, first of all, to ensure that performance is verifiable, to produce a verification plan, to put energy meters in the right locations, to be able to verify the predictions, to be able to adjust the boundary conditions in the model to match real conditions, and therefore to be able to focus verification on like-for-like comparisons between predicted and measured energy use. And lastly, to instill through the protocol a relentless emphasis on the energy performance outcome at every stage of the refurbishment process. I'll now give you an overview of the protocol. First, let's consider the conventional way that European countries assess the energy performance of buildings. If you look in the left-hand column of this slide, it shows each of the main Aldren stages: decision, which means setting the requirements, developing the design, the detailed design, the building works and construction, and then, of course, the in-use phase. The next column shows how we normally assess energy performance. We calculate an EPC before refurbishment at the design stage, and finally after building completion. We think of each stage as providing a lens onto the building, and we have labelled the 3 sequential EPC calculations lenses A, D, and E. What the verification process does is introduce additional energy assessments at the start of the project to inform a more insightful refurbishment, and at the end to check if the refurbishment achieved its energy reduction goals in the performance outcome, the measured performance outcome. Before the design of the building refurbishment is fixed, the existing building is audited to understand how much energy it is currently using and what for. The building model can then be calibrated against the real data, and this will require the model to be run under actual conditions of use rather than the standard conditions used for EPC calculations. After the building has been refurbished and has experienced at least a year of occupation, the verification can take place. Data is collected from the energy meters and compared with predictions for the building, again under actual conditions of use. So I now want to briefly tell you the main steps of the protocol. They are shown here for each stage of the Aldren journey. And the verification protocol is an Excel tool which tells you the key tasks that need to be undertaken at each stage of the refurbishment in order to meet the objectives, which are verifiability and higher energy efficiency. There is, by the way, an instruction manual as a Word document to tell you in detail how to apply each stage. So at the decision stage, it's important to get stakeholder commitment, to apply a simulation model consistent with EU CEN standards, and unless the building is unoccupied, to undertake an energy audit of the existing building. When you are developing the design, you need to calibrate the model using measured energy from the meters, agree the improvements to be undertaken, outline how the building will be controlled, set the performance target, and undertake an independent review of the proposals. During the detailed design, it is important to have the metering plan clarified and to develop the description of operations, which describes how the building will be controlled. During the works and construction stage, you have to defend the building against value engineering, take care with handover and commissioning to make sure the building is set up correctly, finalize the description of operations, how the building should be controlled, calculate the asset rating, and undertake intensive tuning against the description of operations to ensure the real building is being controlled as it should be according to the design. And then in use, you have to track the metered energy performance, diagnose deviations between the metered performance and the expected performance, implement improvements, and track the building's performance over the first year. So the building performance verification tool is used in parallel with the design for testability protocol and is used to signpost and monitor energy performance at all the various stages of the renovation. It also provides a purpose-built repository for predicted and measured energy consumption through the Aldren process and calculates the performance gap both at the decision stage and the in-use stage for each energy system in the building. So how do we go about deciding whether the performance is verified? We have created a traffic light system which we apply to each significant end use, which is defined as an end use with total consumption in kilowatt hours per square meter, which account for more than 10% of the total consumption covered by the European Voluntary Certificate. And the traffic lights say that where the values for the end use between predicted and measured performance are less than 25%, you are given a green light. Where the difference between predicted and actual energy performance is over 25%, but due to different uses by different energy carriers, you may get an amber light. This is because some energy uses are provided by different energy carriers, such as electricity or heating or fossil fuel. Where the difference for each end use, each significant end use, is greater than 25%, you get a red light. So where all end uses are given a green light, the building is said to have a verified energy performance. I want to finish with some key lessons that we have learned from applying the verification protocol to various pilot studies. The first one is that the conventional approach to modeling is not suitably detailed to enable verification. We recommend full compliance with SEN standards for the simulation model, which includes modeling of HVAC plant and their controls. We have also found that the submetering installed in actual buildings is often not ready for verification purposes. It is not correctly calibrated, or it is even not working at all. We have found that building controls are not working as they are designed to, and that can be put right. And we have also found that designers are fixated on their theoretical performance as opposed to the operational outcomes. And some of the independent design reviews which showed that in operation, the building would not perform as desired by the design, these recommendations tended to be ignored. Those are some very high-level lessons from the pilot studies about verification. But to finish, I would like to simply say that if we can achieve an EU-wide building energy performance certificate verified by measurements, this will help real estate owners to justify the deep retrofit that we need, because better performing buildings in reality will appeal more to building occupiers, and this should increase their value, and that will justify the expense of the deep retrofit. Thank you very much for listening.
Well, good afternoon. My name is Paweł Wargowski. I'm associate professor at the Technical University of Denmark. And I'll be probably the one who will speak very little about energy in my presentation, and I'll be the one who will speak about different colors, probably at most. So I'm here to present one of the elements of Aldren procedure that was developed by the project, and this is an element that we call a tail indicator that allows addressing health and well-being in buildings undergoing deep energy renovation. So this is a little bit about my presentation, in which I will present a little bit of a context and present you the whole concept and framework of measuring or addressing health and well-being in buildings that undergo deep energy renovation. We have very little information still from the pilot studies, but those lessons that we learned, I will share with you, and towards the end, I will present some of the future developments for the entire concept and TAIL framework. So Aldren has several objectives, and one of the objectives of Aldren is to include indoor environmental quality in the scope of deep energy renovation. As you know, the deep energy renovation will automatically or unavoidably cause that there will be changes to indoor environmental quality. The changes to indoor environmental quality that will occur as a result passively without any active actions to improve indoor environmental quality are not normally addressed in the process. And they can, on one hand, cause that the indoor environmental quality can aggravate. It may be that it will not change, and in some cases it may cause that it will improve. In case of the improvement, that there will be a benefit, and that this benefit can be actually monetized and included in the overall process of monetizing the effects of the deep energy renovation. So then the question would be, how or can we measure today indoor environmental quality? So if we look at the existing methods for measurement of indoor environment, there exists probably more than 100 different indicators with which we want or we can measure indoor environmental quality and different elements of indoor environmental quality. The four major elements of indoor environmental quality include thermal environment, indoor air quality, acoustic environment, and visual environment. If we look through the building certification schemes, European standards, projects, and also look at the research that is published, we see that different types of indicators are used, and there is no standard indicator or standard method that can be used to measure or rate indoor environmental quality. Those attempts to develop a standard method have been proposed in the past, but none of them is in actual use. And those indicators, although sometimes overlapping in different documents, they could be different. So in fact, if we would like to apply some existing method, there is no existing method that we can quickly take off the shelf and apply to rate indoor environmental quality. Why we need to do that? Well, basically, we need to do this because we need to satisfy the EPBD mandate. The EPBD clearly says that we need to guarantee that indoor environmental quality is not degraded during renovation. In fact, what they say is they refer to the health and well-being, that the health and well-being of the building occupants after renovation is not degraded. Then also EPBD recommends documentation of any improvements of indoor environmental quality after renovation in order to estimate potential additional benefits from the renovation. Those potential benefits can actually improve attractiveness of the deep energy renovation and increase the value of a building on a market, as well as increase the rate at which the buildings are energy retrofit. So because we don't have an existing index and we don't have an existing rating for indoor environmental quality, the project came up with an idea to develop its own framework for measuring indoor environmental quality or rating indoor environmental quality in buildings. And this rating is called Aldren TAIL Index. Well, TAIL is the acronym of the four components of the indoor environmental quality, where T stands for thermal environment, A for acoustic environment, I for indoor air quality, and light for luminous environment. And then overall indoor environmental quality is quantified by the Roman numbers, which is 1, 2, 3, 4, which is complementary with the European standard EN 16798. The concept of the index is indicated on each slide, and particularly on this slide where you have 4 squares that represent with different colors the quality of different elements or aspects of indoor environmental quality, and the circle in the middle that represents the overall quality of indoor environment. The colors are used for simple presentation and also to match with the colors that are used by the energy certificate. So of course the green is the best and the red is the worst. Then we have the amber or orange and yellow in between. Each of the parameters can be characterized by 4 colors. So T can be both green, it can be green, yellow, orange, red, and so on. Here is just an example to represent all 4 colors. Then the middle class, or the class of indoor environment, the Roman number that is presented in the middle, are the 4 categories of indoor environment, from the high level of expectation to the low level of expectation, as I said, compliant with EN 16798. And the color and the category is determined based on the worst category of the indoor environment. So if one of the parameters in tail has red color, then it will be red for category number 4 for indoor environmental quality rating, in order to increase or to create incentive for improving indoor environmental quality. So this is the overall concept of the indicator. The next question would be, so how do we measure all the components that are, or how do we determine the T, A, I, and L in the tail index? So we need to make the decision what we are interested in. As in case what Robert was saying, we are interested here in the actual performance of the building. So and also the tail is related to deep energy renovation. So we are looking for the parameters that may be changed due to the process of deep energy renovation. We know that to improve indoor environmental quality, you can change a lot of parameters, but only some subset of those parameters will change in the process of deep energy renovation. And those parameters need to be included here and in the tail quantification. Then, in order to assure the quick adoption of the idea of using tail index to rate indoor environmental quality, the parameters that are included need to be the parameters that are included in the standards and the certification schemes. We should not come up with the new parameters or new indices that will be difficult to sort of sell on the market. Then parameters that are included should be the parameters that can be measured in order to allow verification and of the rating in the actual building. In case that they cannot be measured, they can be modeled, and there are few that there is one that needs to be actually modeled here. Then there should be parameters, because there is a relation to the aspect of quantification or monetization of the benefits of improvement of indoor environmental quality. There needs to be parameters that have been shown to be related to the to work performance, sleep quality, and so on. So those parameters need to be also included. In the protocol, we do not indicate any tools or indicators that measure directly comfort or well-being. So we do not include elements of such as human assessments or human ratings, in other words, subjective evaluations. So in the process of selection of parameters which are supporting tail, we selected 12 parameters. This is a very crude list, and I understand that this is a very, very crude list, but this is the stage of the development as of today. We also wanted to select parameters that can be measured and can be continuously measured in the buildings. So for thermal environment, we included indoor temperature. For acoustic environment, sound level or sound pressure level or noise level. For indoor air quality, for I, we have several parameters. And the reason for that there is no any single parameter that can express indoor air quality. And also we wanted to address more parameters that are also recommended by the WHO. So here we have several parameters that are typically addressed in the standards, such as CO2 ventilation rate, but also parameters that are in the WHO, World Health Organization, air quality guidelines, such as formaldehyde, benzene, PM2.5, and radon. We have also indoor relative humidity and visible mold, because we developed the index that is not only applicable for offices, but also for hotels. And for the luminous environment, we included two parameters, and one parameter that is related with the illuminance level. It's more related probably to the artificial light. And then because we acknowledge and understand the importance of the daylight, we also include a daylight factor. Daylight factor is the only parameter that needs to be modeled. All other parameters are either measured or are, because we cannot measure visible mold, it's the visual inspection for this parameter. So we developed a very, very detailed manual and protocol on how to rate tail or how to measure tail. Remember that tail is an index that was developed having in mind that we want to measure performance of the building with respect to indoor environmental quality prior to renovation and after renovation. So tail perhaps in the future can be used as an absolute index, but here is more like a relative comparative index, comparing what was the condition before and what is the condition after during occupation of the building. So the measurements with tail should be performed before and after renovation, during same season, during normal operation of a building, in 2 seasons, best in heating and non-heating season. If only 1 season is possible, only then it should be heating season. Measurements should be performed in for at least 1 week in each season, continuous measurements, and in office for 5 work days and in hotels for 7 days, for 7 consecutive days. For the number of measurements in a building, that is also a crude estimation, and the maximum, there should be 10 locations in order to make the procedure cost effective, and only in offices and guest rooms. Each parameter that is measured is classified according to the protocol that was developed and different classes, and is attributed a color, either the green, yellow, and red, and amber, and depending on the class. And then based on those colors, the final categorization of each parameter in tail index is determined. So what we learned from the pilot studies. The pilot studies were performed only in about 20 buildings, more than 10 buildings, and then only during 1 season, and so no complete validation of the protocol could be made, because it was either made before renovation or after renovation. However, except for the complication related to the measurement in hotel rooms, is the access rooms, and small modifications that need to be made to the protocol seem to be reliable and applicable in buildings. One aspect that we observed is that the overall IAQ rating based on the lowest category may be too strict, and then probably in some of the parameters, especially for the thermal environment, few additional parameters should be considered to characterize better the actual conditions. And that, among others, include the air velocity. So to summarize, with the TAIL index, we are offering a consistent and standardized assessment of an indoor environment that ensures health and comfort of building occupants prior to after energy renovation, that can be easily visualized and understood by building owners and decision making through colors. One important issue is that we are not assessing the asset parameters of the building. So we are not assessing what building can achieve, but actually we are assessing the actual performance of a building under the conditions during the measurements. We believe that TAIL needs the future development. And of course, this is a framework that can be further developed. But we think that this framework is on the right track to develop an index for indoor environmental quality. And we have listed a number of improvements for the future. And as particularly for the short time or medium time frame, we believe that we would like to have TAIL as the prediction tool during the process of design of the energy retrofit. Also, we need to verify in more measurements the TAIL index and to see, first of all, its sensitivity to detect the differences between buildings, but also whether a more sophisticated instrumentation, what is the quality of the measurement with a more sophisticated instrumentation. For the long time frame, we believe that TAIL will require an increasing number of parameters included in the framework, also perhaps including occupant ratings, as well as a monetization. So we could compare different TAILs and attribute a certain benefits to that. Okay, if I go back, no, I cannot go back. Okay, so you can read about that, both about the parameters that are included in different certification schemes, and also about the TAIL index in recently published articles. One is in Energy and Buildings and the other in National Journal. And you can basically try to Google with a TAIL index, and then you can probably find it in the literature. Thank you for your attention.
Okay, thank you. Olivier Grelou speaking from CSTB. I will briefly introduce the specific topic on finance, so creating a link between energy performance, health, and well-being assessment that we have just seen with Pavel's, Jana's, and Robert's presentations. So this link with financial valuation of buildings. So first, to introduce the topic in a nutshell, what you have seen is that the previous modules are focused on the evaluation, assessment, and rating of the building performance in terms of energy, health, and well-being. So this work clearly will be undertaken by consultancy companies in engineering and this kind of experts. Now this protocol is quite different in the Aldren overall procedure because our goal is to reach an information gap between financial valuers, owners, investors, and energy engineers. So the goal in applying this protocol is to do a collaboration between engineers and financial valuers mostly. So this is why we propose a methodology to better highlight energy, health, and comfort topics into financial valuation of building assets. There is a topic of risk appraisal for investors and decision makers, and of course, trying to design the best renovation decisions for the building and for its owner. So first, for the context, we know clearly that there is a lack of investment to achieve the European targets of energy savings. And clearly, for the time being, energy savings alone do not motivate high investments in renovation projects and deep renovation projects. In general, the priorities of building owners and real estate companies is rather to improve the building overall amenities and services for their occupants. So now we need to find a way to bridge the gap concerning sustainability topics between the approach of building performance assessment done by engineers and the appraisal of real estate assets that is done by financial analysts. And there is also a lack of transparent and reliable information to be shared on this topic, so we need to find a common ground. We often say in the project, how can a thermal bridge talk to a banker? So this is why the overall approach in this specific protocol is to work out a common language to better highlight the direct and indirect financial benefits that are associated to the topics you have seen before. For instance, the direct benefit is obviously energy savings, and indirect benefits will be a higher attractivity of the building. For instance, if you improve the overall comfort quality and also the productivity of the occupants in the offices if the comfort inside is better. So the protocol is based on three main indicators. So renovation costs, global costs and benefits calculated over the building lifespan. Then a specific risk rating that has been specifically developed for Aldren that is related to sustainability topics and that talks about the obsolescence, potential obsolescence of the building if renovation works are not undertaken in the coming years. And then a third indicator that is the investment worth that is related to the asset value as well as we could have used market value. But it's different for the three topics because the two first indicators, so the cost and the risk, can be directly calculated from the outputs, the indicators that have been calculated in the previous protocols that you have seen. Whereas for the third one, the asset value, it will be calculated by financial valuers based on their own practice and from the information that Aldren assessors will have provided on the performance of the building. So for this specific topic, we don't provide a calculation approach for all the parameters. There is just an overall calculation scheme, and then you will see on the next slide that the details will be up to the financial valuers. To give you more details, you can see the breakup of these indicators in terms of different sub-indicators and sub-parameters. So it's quite obvious for the cost calculation. It's a global cost calculation of the business as usual scenario if you don't undertake huge renovation actions and of different renovation scenarios. For the risk rating, it's rather based on the current building and local market outlook rather than on predictive evaluations of what the market could be in the next years. And for the value, it's related on market parameters like rental growth, discount rate, rental value, which must be evaluated by financial valuers. And so to calculate the investment worth of different renovation scenario packages, we use the standardized discounted cash flow calculation approach on the 15 or 20 years lifespan. What is important here is that all these indicators have been defined based on the thorough review of existing financial standards, so European standards, ISO standards, EVCS, etc. RICS Red Book as well. Now just to provide you some further information on the risk rating. So as I said before, it's really focusing only on sustainability related topics that can have an influence on the choice to renovate or not renovate the building. It's not focusing on other risk considerations like all the operational risk of building management or market risk or credit risk like insolvency of the tenants. So you have four categories. The two first one, the performance and the data management, you have different sub-indicators, and all these indicators can be directly evaluated based on the previous Aldren protocols. The ease to upgrade category is rather based on the discussion with the building owner and the type of ownership and of lease contracts. And then the market uptake will depend on the local situation, whether there is a supply and demand for sustainable buildings, and whether the energy regulatory outlook pushes for deeper renovations. Clearly today, this outlook is not that great, but we have new trends like the Green Deal in Europe. We have also the Décret tertiaire in France, which will force building owners to renovate their buildings by 2030. So this outlook will change, which will put an added risk on the value of the building. For the time being, the weightings for all of these subcategories has not been completely defined. We are currently working this weighting strategy out with financial market players. We collect feedback on the relative importance of each of these criteria. And to see the main interaction with the investment worth calculation, we will let building valuers use this information, which is qualitative and not quantitative for this score, to see what could be the impact on the discount rate in the discounted cash flow calculation. Just to show you the main steps of the protocol through time, we have mainly focused on the two first steps on the left side of the slide. So first, we have a current situation appraisal with obviously data collection about the building characteristic and its performance, and then the financial appraisal of a business as usual scenario if you just replace the technical components of the energy systems and of the building at the end of their lifetime. Then we have to work out different renovation scenarios. So this work has to be undertaken with the renovation roadmap that Marta will just present in the renovation passport in the next presentation. So the main idea is to define renovation action and packages, then different timelines to implement these packages, whether we want to renovate the building just today or after 3 or 4 years, or whether the investors and the building owner will prefer to renovate the building after 10 or 15 years. So now we have defined these different renovation scenarios, and we evaluate the impact on the financial value of the building with building valuers. Based on all this information, the building owner, it's up to him and to the investor to decide to renovate or not the building at a given time. Of course, he will have to engage with stakeholders to detail the financing mechanism and identify the sources of investments, and then to undertake the renovation works. And of course, then you will have the in-use stage of the building, for which you could update the financial appraisal of the building and compare it with your appraisal before renovation. Now you can see more details. So we have seen through time how to apply the protocol. If you are now applying the protocol for one renovation scenario, what do you have to do? So first, you will gather information that will be in the Aldren EVC that Jana presented before, or the building renovation passport that Marta will present in the next presentation. You can see the two icons on the left side of the slide. About building information, characteristics, ratings and targets, measured energy performance, and health and comfort quality through the tail approach. So based on that, the first step is to do the full cost appraisal, which is step 8, as you can see on the screen, that will be undertaken by a consultancy company. Then the financial valuers will collect data about the lease, rent, and occupancy of the building. And the main challenge will be to collect market data to do then the investment worth calculation, also based on the risk rating. So these are the main steps to do the calculation for one scenario, and then all the information that will be outputted from step A, B, C, so for all of these 3 indicators, will be found and added in the Aldren EVT or the Aldren passport. So finally, we are currently applying this approach on several pilot buildings. We have not results yet, but we have had some interesting discussions with different financial stakeholders. So a few key lessons. So first of all, we should use as much as possible the actual conditions of the building used to evaluate the renovation scenarios, because we need details about the real way the building is used. Then the second main feedback is that we know that energy savings alone cannot motivate renovation. So even deep energy renovation scenarios should be coupled with ambitious renovation works to improve the overall building amenities and services, so that we can show higher overall financial gains to the building owner. So this is not really done in the Aldren approach, but this could be done by a collaboration between the building owner and the financial valuers. And then the third main feedback is that obviously distant time horizons are maybe too far away to decide to do renovation works, because you will have a huge uncertainty concerning the regulatory and market outlooks. So when designing renovation scenarios and roadmaps, we should rather focus on short time frames of 10, 15 years and a few steps. And the year at which renovation will be undertaken and paid for through investment will be a key parameter in deciding what to do for the building. So I will now leave the floor to Marta, which will clearly show you also the links with this approach through the renovation roadmap.
So good morning to all. Thank you, Olivier. Let's go straight to the point and start to present with the last presentation of Aldren related to the Aldren building renovation passport and the renovation strategies. Like for the previous presentation, let's discover together, first of all, the context in which the BRP has been developed and its main objective. Then I will provide an overview of the specific structure of the Aldren BRP with a focus on data model and indicator, and the trial application of, in a nutshell, with step description. And finally, I will gonna to resume the Aldren BRP and the world protocol according to the lesson learned from the ongoing application to the pilots. Okay, so what is the building renovation passport? According to the Article 2A of the Energy Performance Building Directive, member states must include policies and action to support targeted cost-effective measure and renovation in their long-term renovation strategies. Such measure can include the introduction of an optional scheme for building renovation passport. In such context, the Aldren BRP want to become a current element in a common European solution. The European Commission has recently admitted that the world is in a climate and environmental emergency, and with the publication in December 2019 of the Green Deal, Europe is trying to turn this situation into an opportunity to improve health and well-being and to set out a plan to cut emission and to boost energy renovation for construction sector, because it's a well-known issue that less than 1% of the national building stock is renovated each year, and this vary between member states, let's say from 0.4 to 1.2%. In order to meet the climate and energy objective, the current rates should at least double. That's where Aldren arrived, trying to guide the expected renovation wave. So let's discover together the Aldren Building Renovation Passport, replying to those questions. When? As we have just said, now is the time, the right time to act, because we need to have and build and renovate in such a way the buildings are 2050 ready. Why? These two, compliancy and harmonization, are the reply, the keywords, the pillar on which we based the Aldren Building Renovation Passport development. First of all, we need to be compliance with the European Energy Performance Building Directive and the metric that he proposed, because I'm sorry, I don't know why it works by itself. Okay. As is stated in Article 2A, he proposed Laura, can you support me? It's changing the slide by itself. I don't know why. Okay, thanks. As I was trying to say, sorry. The directive clearly state and introduced for the first time the BRP as an instrument complementary to the APC, and said that this instrument should be and should stimulate the cost-effective renovation in the term of step-by-step I'm so sorry, I don't know what is happening. I'm not moving slide. Can you support me? Okay. I don't know what is happening. Sorry, somebody can support me on the slide? They are stuck now. Okay, so let's go on trying to fix it up. As we said, the second point is that now is the time to act. We should avoid to create too many and different building renovation passport. We should stay and create something harmonized according to the Europe needs, and not only for the member state, but even for the different target and user needs. How to do that? Aldren BRP would like to reply to these two pillars, structuring the building passport into two main elements. The first one is sorry, I don't know what is happening to my presentation. Okay, the first one is the building logbook that is considered a main repository of all the building data. The two elements in which we structure the Aldren BRP are the building logbook and the renovation roadmap. Why? Because according to the overview on the existing ongoing experience, those two elements are the most well known, and we should be in line with that. What we go in deep and we discover and develop was the structuring of both these two elements. In the case of the build log, the Aldren build log is structuring 6 models, as represented here by the stamps that, according to our idea of path along the process, the building can reach: building picture, energy rating and target, energy verification, comfort and well-being, cost value and risk, and documentation and BIM. And this is mainly represent and has been already presented by my previous colleague. The second part of the passport is the renovation roadmap. That one, and it's structured in 2 modules: the elementary renovation action and the well-known NZEB roadmap, in which we set up with timeline and suggestion according to the cost-effective of packages of elementary renovation roadmap. Okay, the next slide. Okay, so let's discover in deep which are the indicators that compose the model and which is the data model adopted by Aldren. Yes, in literature, the information hierarchy is one of the fundamental and widely recognized model in the information and knowledge literature. Being huge in the number of data to be collected, stored, and managed, we decided to adopt the data information knowledge and wisdom hierarchy, as graphically sketched here, where from the collection of the data, we got to the clustering method data into from data to information, and following rules and actor needs, we set up the knowledge to support decision makers and arrive to the final creation of the building renovation passport. Next slide. Okay, and that's something that that's are the question that help us to create even something that was not a new instrument static. So let's start to understand the past and the current situation from the bottom of the pyramid of the building to go and be to point the future that reveal us the direction. The building structure, the database is organized into different level of granularity to facilitate the data flow and the comprehension according to the user need and expertise, and is composed by three main parts. Next. A sort of metaphor can be seen here: backend, middleware, and front end, where according to the level of expertise of the user of the tool, we can have different data access. The first one is comprehension, the data lake of all the data, where can be feed and managed by a certain expertise. Then there is a middleware, a sort of filtering, clustering, as I presented before. Next. That help the user to go through to arrive at the end to the front end, where we call the Aldren building renovation passport paper version. Why we thought to organize the data model in these three levels? Because we need to allow open data access to different user, but even to facilitate their comprehension without losing data and without losing quality of the process. Next. I'm sorry, I'm not able to manage my slide. Okay. That's a final overview of the process that I just right now presented. The front end is making the big Aldren database that are composed by different database according to all the protocol presented this morning even by my previous colleague. And they are collected within a physical worksheet comprehensive of the main core indicator. And through that, we will extrapolate the main core indicator from each of those models that will constitute the paper version of the Aldren BRP together with the Aldren Energy Voluntary Certificate presented by Jana. And again, next. Okay, so when to do that? Let's finish this overview presenting a sort of application example through the time of the Aldren approach. At the beginning of the approach, we have the actual state, the current state of a no residential building. Next. Then we start collecting data according to that from the existing one or with a survey. Then we start to populate the Aldren build log according to the different model that we have set up. And following, there is a fluent data flow between the two elements of the Aldren BRP, and we start to create the Reno map. At this point, we have the first version of the Aldren building renovation passport. What's next? We don't have to stop here because we said that our main goal is to have something dynamic. At this point, the owner, whatever it is, a pollution energy manager of a portfolio of building, can decide to apply these areas, the packages of renovation measure. Once that those are applied, we should update the data within the build log, and following it, update even the Aldren Reno map. And that's, we have again a new version, step 8, of the Aldren BRP. But the process can go through the time, and we should point out the NZEP target. In this way, we will have always a BRP updated through the time. Okay, next. Let's make a conclusion and summarizing and somehow which are the challenges and the key lesson learned both from the application of all the protocol to the building pilots. First of all, we said we should not act now to be European compliance and harmonized, because we need to create a building renovation passport comparable all over Europe, but also reliable, because expectation should be reached in reality. Secondly, we should create those instruments with a common language, because we should favor communication between all the involved stakeholders. And for doing that, we have set up and provide indicators to financial support and achieve the EU climate targets. And finally, the third point is to be 2050 ready. As we said, and as we presented all together with my colleagues, our Aldren BRP and the whole protocols and instrument that we presented will gonna to cover different topic. And from one, we gave more importance even on health and well-being. And we define clearly the roadmap to go to an NZEB target for the building for which we are gonna to create this building renovation passport. Sorry for the inconvenience, and we are open to question. Join us, contact us. We will be happy to go in deep and share our experience, or try to test together the Aldren BRP and the protocols to your in case buildings. Thank you.
Okay, so thank you for your presentations, and we are out of time for the Q&A, unfortunately. However, I just sent to the audience in the chat a message with the contact details if you have any questions to ask about the projects to the panelists that we had today, then go forward. So just one last thing, since many of you asked this, the recorded webinar and the presentation slides will be available for everyone. They will be published on the Build Up portal, as I said, in the Learn section. You will find all this, but also, of course, in the Aldren website of webpage. So let's see if you have just a final one. Okay. Yeah. So I thank all the panelists for their presentation today, and also thank you to all the participants in this webinar, and apologies for the as we have no time, maybe for a very quick question, as there are 2 minutes left. Let's see. So there are 2 questions about this. Common language to the Hello? Can you hear me? Yes. Are you coordinating with the EU levels project? Can someone maybe answer quickly to this?
I can, Marta speaking from Polimi. All the data model and the indicators presented in the BRP has been classified according to specific source, because as we said, we should be compliancy and harmonized with existing ongoing experience. And so levels, SRE, and other language and framework already set up and ongoing has been considered and merged within the Aldren language.
Pavel Vargotsky from Denmark. We have consulted levels when we were developing tail. So tail basically aligns with what is included in levels as well.
And I can confirm this for energy performance indicators that they were also aligned with levels. So this is why we count also only self-consumption of renewable energy and so on.
Okay, so thank you very much for this last minute question, and thank you all again.
Thank you very much. Yeah. For the consortium, we definitely apologize for the delay. Please don't hesitate to send us your questions. Thanks, Julia, for sharing the contact, and we will make our best to answer your different points and questions. Thank you again. Sorry for the inconvenience.